5.3, we're going to discuss parallelograms today. The next time we do the notes on this will be on rhombuses, so we're splitting it in half. So our objectives are to know the characteristics of a parallelogram and solve proofs on parallelograms. In a parallelogram, ABCD, triangle ABC is congruent to triangle CDA by what? Which shortcut could we use to say that those two triangles are congruent? Alright, let's mark a few things in the parallelogram. Can I say any angles are congruent in this picture? We've got parallel lines. We've got parallel lines, and we've got a transversal. Yeah.
Did you say BAD and
BCA and DAC?
Yeah.
Yep, those two are congruent by AIA. What else could I say is congruent? Yeah.
DAC and DCA?
Yeah. These two would be congruent by AIA. Very good. So then, what else can I say is congruent? Yeah. Yeah, AC is congruent to itself. So then how are the triangles congruent? Which shortcut is that? Eli? Yeah, it's angle side angle. That's a good test question. Right? You may want to put a star by that one. Theorem. A diagonal of a parallelogram forms two congruent triangles. So if ABC is a parallelogram, then we have triangle ABC and CDA are congruent, and ABD and CDB are congruent. And the reason is by corresponding parts in triangle ABC and CDA, angle B is congruent to angle D, BC, is congruent to AD, and AB is congruent to CD, right? Likewise in ABD and CBD, we could say that, what else could we say is congruent? ABD, so in the third picture, what can we say is congruent? By CP. How about angle A is congruent to angle C? All right. Any questions there? Okay. Corollary, if in a parallelogram the opposite sides are congruent and the opposite angles are congruent. So if we have a parallelogram, then AB is congruent to CD, AD is congruent to BC, and angle A is congruent to angle C, and B is congruent to D. That's also as a result of CP, right? Because we know by angle side angle that the two triangles are congruent, so that'd be CP as well. Corollary. Everywhere, the parallel lines are everywhere equidistant. we know the distance between 2 points. The shortest, the distance is the shortest distance, and that's made from the perpendicular. And so we have, if L and M are parallel, then we're going to know that AD is equal to BC. If both pairs of opposite sides of a quadrilateral are congruent, then we can say it's a parallelogram. So if both pairs of opposite sides are congruent, we can say it's a parallelogram. Okay, a proof of this, we could do a paragraph proof. How are we going to, before we do the proof, write it out in a paragraph? Which shortcut are we going to use here to say that the triangle is a parallelogram? What are we going to use if we have the congruent sides? We're going to add a transversal. We've done that in the picture. How are these two triangles in the picture? We can say the transversal is congruent to itself. How do we, come on. How do we know that those two triangles are congruent? Jake?
Side, side, side.
Yeah, side, side, side. So we're going to use the side, side, side idea. And then we'll use congruent angles to show that they're parallel, right? So if I were to do a paragraph proof of this, I would say, draw AC so if we draw AC, then triangle ABC is congruent to triangle CDA by side, side, side. Then by CP, we can say that angle BCA is congruent to angle DAC. So, if I know BCA is congruent to DAC, what can I say? What does that do for me? Those are alternate interior angles and they're congruent. What does that tell me? What does that tell me about the lines if the alternate interior angles are congruent? Christopher?
AD is parallel to BC.
Yeah, so we could say AD is parallel to BC. That's by converse of AIA. So in a similar fashion, with BD, AB is parallel to CD. So by definition, A, B, CD is a parallelogram. That's a paragraph proof. Any questions? Everybody have it? All right. Theorem 5.18. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we can say something is a parallelogram by definition. That means opposite sides are parallel. If all the opposite sides are congruent, we can say it's a parallelogram. Or now we can say if the opposite angles are congruent, it's a parallelogram. There's three ways we can identify something as a parallelogram. If a quadrilateral has two sides that are parallel and congruent, then it's a parallelogram. There's a fourth way. So now you don't have to have both pairs of sides having something. It's just one pair of sides. If it is parallel and congruent, then we have a parallelogram. We're going to prove this one. So we're given AD is parallel to BC and AD equals BC. We're going to prove that we have ABC is a parallelogram. First we're going to show that triangle ABD is congruent to CDB. Then we'll show that AB is parallel to CD. Alright, so let's take a look at the proof. What am I given? Brittany, what am I given? AD parallel to BC. And AD is congruent to BC. That's what I'm given. How do I know that ADB is congruent to CBD? How do I know that? Christopher. AIA. Good. How do I know BD is congruent to itself? Brian. Reflexive. What do I want to say in step 4? What would follow next in this proof? So we've got AD equal to BC, we've got ADB congruent to CDB, and we've got BD congruent to BD. Go ahead and circle or mark those things in your picture up above. Look at the picture up above, and then tell me what we could say as a result. I'll tell you this much, is triangles are congruent. Which two triangles are congruent? Jake.
ABD and CBD.
Yeah. Triangle ABD is congruent to triangle CBD by what? Yes. Side angle side. Right. Step 5. What would I want to say by CP? Brian? Yeah, you could do that. That's one way to prove this, but if you look at the next step, we're wanting to show that AB is parallel to CD. If we're wanting to show AB is parallel to CD, then Jacob, how would we do it?
BAD is congruent, or angle BAD is congruent to angle BCD.
We don't know that. Wait, oh, yeah, you could say that by CP, but that's not going to show with step 6. That's not going to show that we have a parallelogram, that AB is parallel to CD. How could I say AB is parallel to CD? How do I know that? What about ABD and CBD? What would we call them? What kind of angles are they? What's their relationship to each other? Yeah, they're alternate interior angles, right? And they're congruent. So we would want to say that angle ABD is congruent to angle CDB by CP. Those are alternate interior angles, so we could say that AB is parallel to CD by AIA. Right? The alternate interior angles are congruent. So then ABCD is a parallelogram. How do we know that? We've shown a second pair of sides is parallel. So how do we know it's a parallelogram? There's 4 ways. The opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent. Or one pair of, well, this is what we're proving, one pair of sides is parallel and congruent. Which one do we have here? Which case do we have? Okay, we have definition of a parallelogram. The opposite sides are parallel. So step 7 would be definition of a parallelogram. All right. Given parallelogram ABCD with midpoints EF, G, and H on sides AB, BC, and CD, and AD respectively. Prove that EF, GH is a parallelogram. All right. So we're just going to talk through this. Proof. So we have a parallelogram. If we have a parallelogram, we know that angle B and angle D would be congruent because the opposite angles in a parallelogram are congruent. We know that also we would know that AB is congruent to CD and AD is congruent to BC because the opposite sides in a parallelogram are congruent. Then we have EB is going to be congruent to 1/2 of AB, and DG is equal to 1/2 of CD. So now we have EB is congruent to DG. So we could give, let's give EB is congruent to DG, so we could say, we could give them, I'll give EG 2 marks. So now those two are congruent, and likewise we could say that BF is congruent to, so we'll give this 4 marks, BF is congruent to HD. Right? So then how are the triangles BEF and DGH congruent? Are those triangles congruent? Yeah.
Side angle side.
Yep, side angle side. So they're congruent by side angle side. So then by CP, EF would be congruent to DG. And then we could do the same thing with the triangle AEH and CGF to show that FG is congruent to EH, because the opposite sides of EFGH and are congruent, then we can say it's a parallelogram. Both pairs of opposite sides are congruent. All right? Questions? Okay. Theorem. The diagonals of a parallelogram bisect each other. All right? So, if we have a parallelogram, we know the diagonals bisect each other. We're going to explain and prove this in a figure. Okay, so we have a parallelogram. We're given a parallelogram. So we can say that, right? What else do we know in a parallelogram? So what can we mark congruent? Similar stuff we've been doing. Jake.
BC and AD.
Yeah. BC, the opposite sides in a parallelogram are congruent. All right, what else could we mark congruent? Yeah. Bryant.
Angle ABC and angle ABC are congruent.
Yeah. Yes. Let's do. Okay, we can do it that way. So we can say that angle ABD is congruent to angle CDB by AIA. What else can we say is congruent by? Well, let's be consistent with what. That's true. What we can say, I'm going to erase that to get rid of the clutter. But because we first defined these two sides congruent, what would help me more? Which angles would help me more to say are congruent, Madeline?
BA congruent to CD.
Say again?
BA congruent to CD.
That's true, but that's not where I'm going with this. We're trying to show that the diagonals bisect each other. How about rather than say by using C, let's use AIA to say that this angle is congruent to this, right? And we could also use AIA to say these two angles are congruent. Now, what triangles can I say are congruent and why? What triangles can I say congruent and why? Eli.
BBC and AD because
Right. We have angle, side, angle. I'm not sure you named them correctly. You have to make sure you get the correct correspondence. We could say triangle ADE is congruent to triangle CBE. So we've got ADE is congruent to CBE by angle, side, angle. And then how can I show that we have the diagonals are bisecting each other, or the diagonals are equal to each other? The diagonals bisect each other. What would I use to say that, Brennan?
AE is congruent to CE by corresponding parts.
Yeah. AE is congruent to CE, and we could also say BE is congruent to ED, and that's by CP. Okay. Everybody have it? Any questions? Okay. Theorem. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So this is the converse of what we just talked about. If the diagonals bisect each other, we can say it's a parallelogram. We're going to prove that. So we're given A, B, C, D with AE equal to CE and BE equal to DE. And we're going to prove that it's a parallelogram. They even, in the picture, they even showed you vertical angles are congruent. Okay, so they make it easy on you. So step one, what is given? What would be given? Mia, what would be given? AE equals CE, and what else? BE equals DE. Very good. Step two, what do I want to say? Will, what would you say there? It's marked. It's marked in the figure.
Angle BEC is congruent to angle AEC or AED.
Yeah. Angle AED is congruent to angle CEB. That's by VA. All right. So then side angle side. What do I want to say is congruent by side angle side? Adam. Yeah, triangle AED is congruent to triangle CEB by side angle side. Then step 4. How do I know that AD is congruent to BC? Madeline? Nope. We're trying to show that it's a parallelogram. Eli. Yeah, that's CP. And then also by CP we can say that ADE is congruent to CBE. So then what can I say because of the congruent alternate interior angles? Namely ADE and CBE being congruent. What could I say? By CA. No, by AIA. What could I say? Okay, I would say that AD is parallel to BC. So now I have that the opposite sides are congruent and parallel. So then we have step 7, opposite sides, parallel and congruent. Okay, any questions? No questions. Okay, good.